So how do we use this uncertainty? It's all well and good to be able to say, yes, I can calculate absolute, I can identify absolute uncertainty, I can calculate percentage uncertainty. When do I use it? It's easy, let's walk before we run. Okay? Good thinking though, the state had uncertainty that we needed to deal with like this. What was the absolute uncertainty for our width? Percentage uncertainty for our width? Can someone give me an approximate number? What did we get for your width? What did you get? Did someone have 210? Did someone have 210? Yeah. What did you get for your width? 0.21. 0.21. So your width was 210 plus or minus?
It was 0.29, not
0.29%. And your length was what? 295 plus or minus 0.17%. Okay?
Yeah.
That's our width and our length. These are exactly the same thing. Liam, are you happy that these are the same thing?
I've read the wrong one out.
Okay, that's good, but are you happy that these are the same thing?
Yeah.
Okay, they're exactly the same thing. So why do we calculate into percentage uncertainty? And the reason is because if you want to use uncertainty in calculations. So what's something I might want to do with my length and my width of my page? What can I calculate? Area. So I want to find out the area, with a better pen, of my page. So what does area equal? Length times width. So you'll never guess what we're going to do. Multiply those two values together. See what we get. So we get 297 times 210. And what do we get as a value for that? Yes?
62,370.
62,370. 17, whatever you get. 70 sounds better. Millimetres squared.
Yeah.
What have I not accounted for yet? The uncertainty. And this is why we do it in percentage, because here I'm going to put plus or minus and I'm going to add my two uncertainty percentages together. So it's going to be 0.29 plus 0.17%. Why do I add my percentage uncertainty?
Make sure it's accurate.
Make sure it's accurate. What am I assuming? Is this going to give me more or less uncertainty than the individual percentage? More. The reason I do that is because I could be a little bit off in the positive for my length and a little bit off for the positive in my width as well, which will compound my error. Does that make sense? So I assume worst case scenario. So I add them together. So I'll just run through that process again, just so we're really clear. With my absolute uncertainty, the first thing I do if I have to do calculations is convert it to percentage uncertainty. I then complete my calculations as normal, but I add my percentage uncertainties together. What's the other value of that? What's the unit for these? Do we often do calculations in physics where we're dealing with the same unit together? Or not? So when you're doing your stake report, when you're multiplying time by, say, temperature, what are the units for time? What are the units for temperature? So you're not dealing with the same unit there, are you? By doing percentage, what have we taken out? Taken out the unit. I could have had this as kilometres and millimetres and it wouldn't have mattered because I'm putting them into percentages. Does that make sense? So the process goes absolute, convert that to a percentage, do your calculations as you normally would, but add your individual percentages up. So I should have plus or minus 0.6446%, plus or minus 0.46%. What do I want you to do now? What do you think I'm going to ask you to do in about 3 seconds time? Convert this into a
Fraction.
We've got a percentage I want it back to. Absolute uncertainty. How do I do that? How do I get it back? Here's my formula. Reverse it. Okay, so I have to undo this to get absolute uncertainty by itself. Good luck. Get through those. Calculate the area by yourself and then calculate the area of the thing that you measured. You know how I asked you to measure to another thing? Yeah. Calculate the area of that with percentage and absolute uncertainty.